All right, my mathletes, it is time for more MathCounts prep. Today we're going to go over the coordinate geometry stretch, the things that you're going to need to know to complete this worksheet. So first of all, coordinate geometry means that it's geometry that happens in the coordinate plane. So you're going to get points, you're going to get segments, you're going to get lines, and even today we're going to see that we get circles sometimes. So anyways, I've got points. So here I've got point AB. It goes from 1, 4 to 5, 1, and then I've got CD here at -5, -2, and D at -3, -3. The first thing that we're going to look at is something called the midpoint. A midpoint is, well, just like it sounds, it's halfway. So it's the point that's halfway in between it. Now there's a nice long formula that you can use for this. Basically this formula says if you add the x's, so on AB this would be 1 and 5, and then divide by 2, and then add the y values, so 4 and 1, and then divide by 2, that will be the midpoint. And what that's doing is it's just taking the average. So when I add two things together and divide by 2, that's just the average. So midpoint, halfway, average, yeah, it sounds about like the same thing. So that's all this big formula is telling us, is that we should take the average of them. So let's look at DC, and let's find the midpoint of this one. All right, so DC has x's at -5 and -3. So let's see. Okay, so the midpoint of DC, we would do -5 plus -3. And then we divide by 2. And then for our y coordinates, we take -2 and 3. So -2 plus 3 and divide by 2. So what do we get? Well, -5 plus -3 is -8, and -8 over 2 is -4. And if I've got -2 plus 3, that's 1, and 1 over 2 is just 1/2. So it says the midpoint should be at -4, 1/2. So let's go back 1, 2, 3, 4, and up 1/2. This should be the midpoint. Well, it looks about right. That does look like it's halfway. Second thing we're going to look at is slope. So slope is the change in the y value, so how much the y values are changing by, divided by how much the x values are changing by. So let's just look back at this problem that we're doing here with CD. And if I look at my change in my y values, so change means we're going to subtract them. So if I do 3 minus -2, so that's my change in my y values, I get 5. And if you count it out, 1, 2, 3, 4, 5, yes, it does look like it's increasing by 5. So when I'm looking at my slope, and we call slope M, and we'll show you why later, and we're looking at our change in our y's, we could do the formula, which would just be taking our y values and subtracting them, so like -2 minus 3, or I could do 3 minus -2. You can go backwards or forwards. So if I do -2 minus 3 over the change in the x's, now that's side to side, -5 minus -3. So -5 minus -3. So what are we left with? We have -5 in the numerator. In the denominator, we've got -5 plus 3, which is -2. So we would say, after reducing this, that our slope is 5 over 2. Now, we don't actually need to have the equation because you can count out your slope. So this one is going up because we're doing the change in y's first. Up 1, 2, 3, 4, 5. So we can see that it's going up 5 and then over 2. So this is 5, this is 2, so our slope would be 5 over 2. Now, the midpoint can also be found by having half your slope. So since it's going up 5 and over 2, to go halfway, I could go up 2.5 and over 1, and there's your midpoint. So sometimes we don't even need the formulas. As long as you know the slopes, a lot of times you can find it without doing the formulas. Last thing is our distance formula. The distance formula says that it's the distance between 2 points is the square root of the x's subtracted then squared plus the y's subtracted then squared. Okay, so let's go ahead and do that one real quick. So the distance is going to be equal to the square root of my x's subtracted from each other. So I'm going to do -5 minus -3. So -5 minus -3. And I'm going to square that number plus the change in the y's. So -2 minus 3. And then I'm going to square that number. So here I'm left with -5 minus -3. That would be -5 plus 3, so that's -2 squared, plus -2 minus 3. So -2 minus 3 is -5 squared. So -2 squared is, so that's -2 times -2, that's 4. And -5 squared would be -5 times -5, that's positive 25. And we get the answer of the square root of 29. Now, what's the square root of 29? Well, we know that the square root of 25 is 5, so this is a little bit more than 5, but less than 6, because the square root of 36 is 6, and so this doesn't quite make it up there. So it's 5 point something, who knows? I mean, we could calculate it, but we're not going to waste time on that. So that's our distance. Now, what I want you to see is if you know the slope, then you don't have to do all this work for the distance formula. How do I know that? Because look at the equations. Here you've got y2 minus y1 in your slope. Well, what's this? y2 minus y1. Those two numbers are the same. So the number in our numerator for our slope is this number here, and that's why I got 5 squared and got 25. And then the number in our denominator of our slope, x2 minus x1, is this number here, x2 minus x1. So the number in our denominator from our slope is just this number, -2, or positive 2, doesn't matter when you square it, and that's where I got the 4 from. So a really quick way for finding the slope is I can just go, okay, this is up 5 and over 2, so I'm going to take 5 squared plus 2 squared and then take the square root, and you get 25 plus 4, root 29, done. Don't have to do that whole equation there. The other way that you can look at it is those of you who have done the Pythagorean Theorem, you can make a right triangle here. And you guys know that a squared plus b squared equals c squared. The diagonal part is always going to be your c squared. So if I do like if I make this a and this b, so that'd be 5 squared plus 2 squared equals c squared. So I get 25 plus 4 equals c squared. So I get 29 equals c squared. And then I want c, not c squared, and the opposite of squaring is to take the square root. So c would be equal to the square root of 29. So you could do it like that. Lots of different ways. Personally, I like to find the slope and then just plug in the two numbers from the slope into this part of the distance formula, and it goes really fast. All right, so let's do AB with those same steps. So let's find the midpoint. Okay, so we can do our whole formula where we add the two numbers, so 1 plus 5. For my x's and divide by 2, and we can take our y's, 4 plus 1, and divide by 2. So 1 plus 5 is 6, 6 divided by 2 is 3, 4 plus 1 is 5, 5 divided by 2 is 2.5, or 5 halves. So there's our midpoint. Now let's find our slope for this one. This one goes down 1, 2, 3, so it goes down 3, direction matters. This one was going up, this one's going down. And then over 1, 2, 3, 4, so over 4. So this one has a slope of -3 over 4. So that's our slope. Remember, you can do the y2 minus y1 over x2 minus x1 to find those same two numbers. Now let's do half of going down 3 and half of going over 4. So instead I would go down 1.5 and over 1, 2, and there's the exact same point I got here. 1, 2, 3, 1, 2, and a half. There's our midpoint. So you can take half your slope and find the midpoint there. Last thing is to find our distance. And those of you who know the Pythagorean Theorem already know that our answer is going to be 5. But anyways, so if I can use my slope numbers, negative 3 times negative 3 is 9. 4 times 4 is 16. So in the distance formula, remember these parts are the 16, so the 4 times 4, and this part is the negative 3 times negative 3. So we're just making a shortcut here. And then we get the square root of 25, and the square root of 25 is 5. All right, so midpoint, slope, and distance. That'll help you out quite a bit on the first couple problems for the coordinate geometry stretch. And then it's going to get into some linear equations. Linear equations are just equations that make lines on the coordinate plane. And generally, we want to keep them in the format y equals mx plus b. So x and y, so these two are points on the line. So any point on the line could fit in here. So those are our x's and y's. M is the slope, and we were just finding the slope up here. The slope is really just telling us how steep the line is. Going back to this one, 5 over 2, a positive slope means it's going uphill, and the bigger the number, the steeper it is. See, this one's negative 3 over 4. That's a smaller number. That's why this line isn't as steep as the previous one. And then a negative slope means you're going downhill. So the slope is just telling us where or what kind of steepness we have to our line. The y-intercept is where we're crossing the y-axis. Now up here, we didn't quite cross the y-axis, but if I extended this line, it'd be like where I cross the y-axis up there. Those are the two things we need for the slope. So here I've got y equals mx plus b. If we know our slope, we'd plug that number here. And if we know our y-intercept, we'd plug that number here. And then that would be the equation. So let's say that we want to find the equation line. We know our slope, but we don't know the y-intercept. We just know that our point goes through 6, 4. Well, there's two ways you can do this. You can do the long method of actually graphing it. So 6, 4, where's that going to be? So let's say I've got 6, 4, 1, 2, 3, 4, 5, 6, 1, 2, 3, 4. So there's 6, 4. My slope is 1/2. That means up 1 over 2, up 1 over 2. And I can also go down 1 backwards 2, and down 1 backwards 2, and down 1 backwards 2. Oh, there we go. We've got a y-intercept. That's the y value of 1, right? So we could say our equation is y equals 1/2, because we plug in the slope number for m, x, and then we worked backwards and found out that our y-intercept over here was 1. So plus 1, because it crosses the y-axis at 1. Now we can do this algebraically as well. We have the equation y equals mx plus b. And in the problem that we've been given here, this is x and y, and this is m. But to find the equation of the line, I need m and b. Those are the most important parts. So what I'm going to do here is I'm going to substitute for y, x, and m, and then solve for b. So instead of y, I could plug in 4. Instead of m, I could plug in 1/2. Instead of x, I could plug in 6. And then plus b. So on this one, so again, I plugged 4 into y. The slope was m, so I plugged that here. And the x value was 6, so I plugged that here. Now I'm going to solve for b. So I get 4 equals 3 plus b. Subtract 3 from both sides. And I get a y-intercept of 1, which is exactly what we found over here. The y-intercept's 1. So our equation would be y equals 1/2 x, our slope goes there, and then plus 1, our y-intercept goes right there at the end. All right, almost done. Perpendicular lines and parallel lines. So perpendicular lines have opposite and reciprocal slopes. Okay, so let's find the slope of this line first. So it goes down 1, 2, 3 over 1, 2. So this line has a slope of -3 over 2. If I want to have a line that is perpendicular to that, perpendicular means that they cross at a perfect right angle. So if I want a perfect perpendicular line, we need an opposite reciprocal slope. So we have the slope of -3 over 2. Opposite means that if one's positive, the other one's negative. So this one's negative, so our slope would have to be positive. Reciprocal means that I'm switching the places of the numerator and the denominator. We might call these inverses as well. So the 2 would go to the numerator, the 3 would go to the denominator. So an opposite reciprocal slope would be 2/3. All right, so let's say that I want a line that passes through this point and is perpendicular to this line. Okay, well, I would use my slope here. So I know this slope is -3/2. So I know that my slope has to be 2/3. So that means up 2 and over 3, or I can go down 2 and backwards 3. And now we have the line that's perpendicular. That is a perfect 90-degree angle right there, because this one had a slope of 2 over 3, and this one has -3 over 2. Now let's say that I wanted it to be parallel. Parallel lines are just lines that don't cross each other. Well, they had to be in the same plane, but anyways, they can't cross each other. So in order to have parallel lines, they have to have the same slope. So let's say I wanted to pass through this line, this point, and be parallel to this line. Well, all I would have to do is have the same slope. This line has a slope of -3 over 2, so I'm just going to go down 1, 2, 3 over 1, 2. And now I have a line that's parallel to it. They're not going to cross each other. Okay, and now we've got a parallel line because they have the same slope. All right, last one. Ooh, fun stuff, equations of circles. Okay, so the fundamental equation of circle that we're going to use to graph is x minus h squared plus y minus k squared equals r squared. Now, x and y, again, are points that are going to be on the circle. So any xy is going to be a point that's actually on the exact circle. H and K is the center of where the circle is. Now notice here that this is -h and -k. So that means that if I've got like a negative number here, it's actually positive in the center of the circle. We're going to see that in a second. Finally, R is the radius. So if I've got a number here, I would take the square root of it, and that would tell me what the radius of the circle is. Let's start with something really basic that you'll see on this assignment. X squared plus y squared equals 25. All right, so x squared plus y squared equals 25. The h is 0 and the k is 0. I don't see any number with the x being squared or any number being at the y being squared. What does that mean? It means that the center is at 0, 0. So if I'm graphing this, 0, 0 would be one of my points. Now this one, the r squared value is 25. So what number multiplied by itself equals 25? Well, that would be 5. So my radius is 5, so I would go up 1, 2, 3, 4, 5. So my circle would go through that point. 1, 2, 3, 4, 5. It would go through this point. 1, 2, 3, 4, 5. It'd go to this point. And 1, 2, 3, 4, 5. It'd go to this point. So I could draw a circle between those points. Now the question becomes, are there any other points that might work? Now what we can think of is our perfect squares, which are 1, 4, 9, 16, 25. Are there any smaller perfect squares, two different ones, that would add up to 25? And there are. 9 and 16 add up to 25. Now why am I bringing this up? Because this gives us extra points that we could plot. So if I take 3 squared, that gives me 9. And if I take 4 squared, That gives me 16, and 9 plus 16 equals 25. So what does that mean? It means that I've got a point at 1, 2, 3, 1, 2, 3, 4. This point should be on the circle. I could switch these numbers around and go 4, 1, 2, 3, and that point would be on the circle. Remember, when you square negatives, they become positives. So I could do 1, 2, 3, 1, 2, 3, 4, and that point would be on the circle. Or I could do 1, 2, 3, 4, 1, 2, 3, and that point would be on the circle. And I could keep on doing that and use my negatives over here, 3, 1, 2, 3, 4, and then 4, 1, 2, 3, and 3, 4, and 4, 3. So basically, what am I doing? I'm creating all of the points that would be making this circle, and curves are hard to make. Making curves, because they're fun. Oh, that one was actually pretty good. Oh, curves. There you go. Oh, that wasn't very good. What was I thinking? Oh, this is pretty good. Better than average. Nice. All right. There you go. So I made a circle. All right. So what happens if we've got something like this that says x minus, there you go, x minus 2 squared plus y plus 1 squared equals 16. All right, so the h and the k, now we have h's and k's. So this one right here, -2, the h value and the k value, remember we take the opposite because this equation up here says minus h. So h must actually be +2 because if you plug in 2 here, it becomes negative. So our h value is 2. Our k value, we have to take the opposite, is -1. What does that tell me? It tells me that if I were graphing this circle right there, the center of the circle would be at 2, -1. There's the center of that circle that we're doing right here. And then this is the r squared value. So what number multiplied by itself equals 16? 4. So that would tell me the radius is 4. So I could go up 1, 2, 3, 4. I could go over 1, 2, 3, 4, down 1, 2, 3, 4, and then over 1, 2, 3, 4. And there's my circle. This is way harder to do. Oh, that's not bad. That's not bad. That's not bad. Oh, that wasn't as good. Oh, that was really bad. I'm losing it. I'm losing it. I don't have the mojo anymore. All right, anyways. Wow, that's a sad looking circle. I would suggest that you go to Desmos and use the Desmos.com and use the graphing calculator that they have here to play with some of these equations so you can really see the relationships if you haven't dealt with linear equations before or if you haven't done circles before. That will kind of help you on this assignment. Thank you very much. That is all I have. Bye-bye. Do some math.